Have you ever stopped to consider what would happen if all the air in a room, or even the air surrounding you, suddenly vanished into thin air? What immediate effects would we observe? We walk through air every day, breathe it in and out without a second thought, and feel it as wind brushes against our skin, rustling the leaves of trees. But we rarely stop to think of it as a tangible substance, something that's actually there. Air, despite its invisibility, has weight and constantly pushes on everything around us, exerting about 14.7 pounds per square inch on your body at this very moment. That's quite a bit of force. You don't typically notice this pressure because your body is ingeniously designed to push back with equal force, maintaining equilibrium. But what if we could somehow defy nature and remove all the air from a given space? That's the essence of a vacuum, a space utterly devoid of matter, a true void. Imagine a perfectly sealed box, and then picture every single atom, every molecule being meticulously sucked out, leaving absolutely nothing behind, pure, unadulterated emptiness. Nature, as the saying goes, abhors a vacuum. This is because higher pressure from the surrounding environment always relentlessly tries to rush in and fill any empty space that it can find. This fundamental principle is the driving force behind everything, from the simple act of using drinking straws to the vast emptiness of outer space. When you take a sip through a straw, you're essentially creating a tiny vacuum inside the straw. The higher atmospheric pressure outside then pushes the liquid up and into your mouth. We unknowingly create these small vacuums in our daily lives all the time, often without even realizing the physics at play. The profound idea of emptiness, of absolutely nothing, has captivated and challenged thinkers and philosophers for centuries. For a significant period, the prevailing belief was that a true, perfect vacuum was simply an impossibility, a concept that could never exist in reality. But the relentless pursuit of understanding nothing, this seemingly empty concept, ultimately led to some of the most significant scientific breakthroughs in history. It fundamentally forced us to completely rethink our understanding of space itself, the very nature of matter, and the fundamental forces that govern our vast and complex universe. From what started as a seemingly simple question about what would happen if air disappeared, we unlocked a cascade of discoveries and innovations that have profoundly shaped the world we live in today. Sometimes the most unexpectedly powerful thing in the universe is, paradoxically, absolutely nothing at all. Next, let's delve deeper and see precisely how the quest to understand and create a vacuum has dramatically changed the course of history. For centuries, the concept of a vacuum was relegated to the realm of philosophical debate. People simply believed a vacuum was impossible. Nature, it was thought, feared emptiness, a concept known as horror vacui. This deeply ingrained belief began to change in the 1600s, a period of immense scientific upheaval, when Evangelista Torricelli, a brilliant student of Galileo, started questioning the accepted wisdom. He tackled a very practical problem. Specifically, why could pumps only lift water to a certain height and no further? What was the limiting factor? He realized the prevailing explanation of suction was incorrect. It wasn't suction, but rather the weight of the atmosphere, air pressure, pushing water up the pipe. To prove his theory, Torricelli devised a clever experiment with mercury, and this experiment definitively proved that a vacuum could, in fact, exist. In doing so, he inadvertently created the first man-made void, a space devoid of matter. This groundbreaking discovery sent shockwaves through the scientific world. Inspired by Torricelli's work, Otto von Guericke soon built an air pump, a device to remove air from a container, and he famously demonstrated that atmospheric pressure could hold two tightly sealed hemispheres together with such force that teams of horses, straining with all their might, couldn't pull them apart. That is, not until air was deliberately let back in to equalize the pressure. These dramatic experiments provided undeniable proof of the immense power of atmospheric pressure and, crucially, the tangible reality of the vacuum. The age of nothing, the era of understanding and harnessing the power of the vacuum, had officially begun. Torricelli and von Guericke's groundbreaking discoveries, achieved through meticulous experimentation, sparked an engineering revolution, a complete transformation of how we harness energy and power our world. Early steam engines ingeniously used vacuums, a novel approach at the time, to harness atmospheric pressure, turning it into a driving force. This innovation was pivotal, powering the Industrial Revolution and reshaping society. James Watt's improvements made engines more efficient, marking a significant leap in engineering, fueling global industry and transport, connecting distant lands and accelerating commerce. The invention of the light bulb depended on vacuums, a crucial element often overlooked. Removing air let filaments glow without burning out, providing light for homes and streets. Every vintage bulb is a piece of vacuum tech, a testament to its vital role. The ultimate vacuum is outer space, a vast, almost perfect void. It's the emptiness between planets and stars, a realm of extreme conditions. Understanding vacuums on Earth helped us explore space, paving the way for interstellar travel. Rockets work by expelling mass, generating thrust to propel themselves forward, and in a vacuum there's no air resistance to slow them down, allowing for maximum efficiency. Mastering vacuums was key to launching the space age, enabling us to reach for the stars. From engines to electronics, vacuums have played a critical role. The power of nothing changed everything, driving innovation and progress across industries. But vacuums aren't just for history. They are not confined to the past. They're everywhere today, integral to countless modern technologies and processes. Vacuums are hidden in everyday life. Vacuum sealing keeps food fresh by removing oxygen, stopping bacteria and mold. Freeze drying uses vacuums to preserve food for years. Computer chips are made in ultra-clean vacuum chambers. One stray particle could ruin them. Even your vacuum cleaner uses low pressure to suck up dirt. Thermos flasks use a vacuum layer to keep drinks hot or cold by blocking heat transfer. In science, particle accelerators use vacuums to speed up particles without interference. Medical tools and electron microscopes rely on vacuums for precision and sterility. The invisible power of nothingness shapes what we eat, use, and discover. Vacuums are everywhere, quietly enabling modern life. But what's next for vacuum technology? The future of vacuums is just beginning. Quantum computers need ultra-high vacuums to protect delicate qubits from interference. Advanced materials are made in vacuums, enabling new coatings and solar panels. Space exploration will demand even better vacuum tech for life support and manufacturing in orbit. The vacuum of space is both a challenge and an opportunity. Our quest for nothing keeps driving innovation. What new breakthroughs will the perfect vacuum unlock? Share your thoughts below. What fascinates you most about the power of emptiness?